This video is to go over lesson 2.03 homework packet 2A. Number 5, assume C triangle, problem number 5, assume triangle CAT is congruent to triangle DOG. List all the corresponding parts. I'm going to do just a little bit. So it's going to be angle C is congruent to angle D, and segment CA is congruent to segment DO, right? So let me just do the CAT. If I write the triangle this way, I gotta go DOG this way, because for first triangle, this one I said CAT, you know, left bottom, top, right bottom. So I gotta go to left bottom, top, right bottom. Okay, so angle C is corresponding to angle D. I shouldn't use that tick mark, and I kept saying tarry mark, but it actually is tick mark. I'm sorry. And also CA is corresponding to DO, so that's what I have. And you can have more. You have actually more, so this is more. Problem number 6. You are given that triangle DFG is congruent to triangle CHK. Which of the following statement is true by corresponding parts of corresponding figures are congruent? So problem number 6, we have DFG. Again, I went left, top, right. So I got to go to left, top, right to write CHK. So if you have this, these two are congruent. Okay, C corresponding parts of congruent triangles are congruent, right? So can you say measurement FGD, which is this one, is the same as CKH? Can you say that? So you're talking about this angle. Are these the same, or how about this? CH and DG, are these the same? Maybe I should write it like a little differently. This looks like a equilateral triangle, so well, anyways, problem 7, use the figure below. Some pairs of triangles are certainly not congruent. List any pair of triangles that appear to be congruent. So we have something like this and this, I guess. We got E, D, A, F, G, B. Again, I have a terrible drawing, but which one looks exactly the same? I would say this triangle and this triangle looks the same. What else looks the same? You don't really have to use the triangle postulate, but you can just simply say it, you know, which one looks like it. Problem 8, you can compare figures in many different ways. Congruent is a shape comparison. Area is a quantitative comparison. Use what you know about area to answer the following question. A. If two polygons are congruent, must they have the same area? So if, let's say, you have exactly the same polygons, it can be pentagon, hexagon, whatever. If you have exactly the same polygon, do they have to have the same area? Explain. B. If two polygons have the same area, must they be congruent? So it's the converse of the first statement. If you have, let's say, whatever the polygon, whatever, you know, dodecagon or whatever, if you have those that have exactly the same area, not the shape, but if they have the same exact area, do they have to have the congruence? Do they have to the shape has to be exactly the same, and the size as well? If you think about the quadrilateral, it might be easier to see it. If they have the same exact area, and one has a square, and can you actually make a rectangle, which is not a square, with the same exact area? If so, then the statement B will be false. Problem 9. The figure below contains 3 congruent triangles. So we have number 9, A, B, D, E, C. Something like this. A, B, D, E, C. A. Write the correct congruent statement for the three congruent triangles. So if I decide to write triangle ABC, right? This looks like a 90 degrees right there. Is congruent to what? Triangle BCD or CBD or BDC or whatever, right? And would that be congruent to triangle CDE or CD or EDC or ECD, or that's the question here. Problem number 10. The figure at the right is not drawn to scale. The markings indicate which pairs of segments and which pair of angles are congruent. Segments that appears to be straight are meant to be. So straight line is a straight line, but it's not drawn to scale. There's actually some tricky. It looks like the same, but it actually is a little tricky. Assume measurement angle F is 80 degrees, measurement angle H is 50 degrees, and measurement angle B is 40 degrees. What are the measures of angle A, angle E, and angle D? So, number 10, we've got something like this. Doesn't have to be drawn to scale. So we've got this, one tick mark right there, two tick marks for E, two tick marks here, three tick marks here, three here, one tick mark, it's A, three tick marks, B, D, C, F, G, H, A, B, C, that's C, okay, H, I, J. Now, by the way, they don't use I so often because it looks like one, So let's say F is 80 degrees. That tells us that one tick mark right there, that's going to be 80 degrees as well, because you got the same mark right there. If that's 80 degrees and H is right there, well, that has actually two marks. That is 50 degrees. That tells us that this will be 50 degrees. And that is measurement angle B is 40 degrees, therefore these are 40 degrees, right? So can you say angle A, well I just said that, angle E and angle D. So D doesn't have any mark, but somehow if we know these two angles, we can say that, we can find out here. And B, use a ruler and protractor to draw the figures to scale. Actually, we don't have one, so if you have one at home, if you could do it, that's great. If you cannot, don't worry about it.